Hello everybody, and welcome to the next video on functions. In this video I will introduce you to two new concepts, the concept of a void function and the concept of passing by reference. So in general it is a bad idea to introduce two new concepts at the same time. Generally speaking, it is better to do things sequentially. So show you what a void function is in this video, and then in the next one do passing by reference, or vice versa. However, these two concepts are only really useful together, at least for us anyway. So since for us they are only useful together, we're going to spend two videos on these things, but I'm just going to introduce them together at the same time and then show you some of their power together next time. So first, let me introduce the idea of a void function. Here's some motivation. Suppose you want to write a function whose only purpose is to print a vector. What would such a function look like? In particular, if you think about the declaration of a function, you have to think about the return type, the name, and what you hand to the function. So in this case, it's sort of obvious what you hand to the function. For this function to do its job, you have to hand it a vector. Right, so you feed a vector in there, and then what does the function do with the vector? It prints the entries using, I suppose, the same for loops we've been using. And then once it's done printing, what is there left for it to do? In other words, what kind of return value would the function have? It's not clear to me that you need to return anything. You don't have to give anything back. You have done this printing task, and now you are done. Such a function actually doesn't really need to return anything. We don't need to create something new and give it back. You simply print and then you are done. So to compare and contrast with what we have been doing, here are the functions from last time. They are still here. The declarations are here. So let's think about this first one. It's called board a winner. You feed it the vote totals. What does it do? It creates something, namely a character vector, and gives that creation back to you. It gives you something new, right? And that new thing is a list of winners. What about this average function? What do you hand to it? Of an integer vector. What does the function do? It takes that vector and creates something new, which is a float, and it's the average, and it gives that back to you. Right? So you feed stuff in, the function does something, it creates something and gives it back to you. Therefore, in main, I can do things like, so I already have a vector created here, right? I can say float average equals average of this vector. Okay? Average of my vector. It has created a float that it is given back to you. Therefore, it makes sense to do something like this. Float average, and then you put the value in there, So AVG is now whatever the average of that list is. Okay, so finally, sum and solutions of quadratic equation, right? Both of these functions, what did you do? You handed it some stuff. It created a new vector and gave that back to you. In this case, a sum vector. In this case, a solution vector, okay? But in all these cases, what happened? You fed something in, it gave it back to you. That thing it gave back, you could store somewhere if you wanted to, etc. Okay, void functions don't do that because, well, not slideshow, there we go. Void functions do not do that because they're not trying to create something new. If you want to print something, you don't need a float or something to do that. You just input the function and off you go. So I'll show you an example of that in a second, but here's how you declare a void function. You just write void here, which tells the computer that you are not going to return something, the name of the function, and then what you hand it. So let me show you two examples of this, printing vectors basically. So back here in the code, I'm going to create two functions. The first, print 1D vector. And let's just say we're dealing with integer lists. So what do you need to hand that function? You need to hand it a list, and then you're going to print it, and then you are done. Nothing created. Same with 2D. Now you have to hand it a 2D vector, like that. Okay, let's go create these guys down below. I've already created some vectors in main to play with, see, so let's just go right past all of that. Okay, to print a list, what happens? You start at the beginning, you go up to the size of the list, I++, right? The same for loop we've been dealing with before, list, bracket I, space, I guess, or new line, depending on what you want, okay? Okay, so back up here in main, I can now just basically speak English. I can say print 1D vector. Well, which vector do you want me to print? Well, my vec, I guess. I mean, that's the only one I have there, right? So what happens now? My vec gets fed into this function. The value of my vec is passed to list. So list now is playing the role of my vec, and you will just print it. So let's run it and see what it does. 2, 7, negative 1, 10, 11. That is indeed what that vector is. Okay. So what have you done? You have taken this for loop that used to be all over main every time you wanted to print something, and you have now removed it from main as something you can reach down and grab whenever you want it. Okay, so you have outsourced that for loop outside of main. I also have a table in main that I might want to print. Okay, so if I want to do that, I have to do something like this. I equals 0, I less than rows of the table, I++, and then, so I'm just going to write here the same nested for loop structure we've had before, and then print. So it's yelling at me a lot, so just ignore that for now. I'll just put a space in between and then a new line. So in other words, just take that nested printing structure and punt it outside of main and just reach down and grab it when you want it. The issue here, of course, is that I need to know what the number of rows of this table are. So let me call this table just to make it table. It's more fitting of the English here. Table. I need to know how many rows are in that table, how many columns are in that table. Okay, so let me teach you a new command here. If you ever want to know the number of rows in a table, table.size does that. Okay, when you are dealing with a two-dimensional vector, dot size does not tell you how many entries there are in the table. Okay, so if it's a 2x3 table, it's not going to tell you 6 for the 6 entries. It's actually going to tell you the number of rows. So again, with a two-dimensional vector, if you write table.size, that is the number of rows, not the number of entries in the table. So anyway, that's a fast way to get the number of rows. Now the question is, how can I get the number of columns? Well, the number of columns is the size of the first row. So again, this notation here, table bracket 0 with no second coordinate, that means the 0th list in the table, which means the 0 row, or if you like in English, the first row. So I'm just going to get the size of that. So in other words, if you have a 2x3 table, and this table back up in main is 2x3, okay, table bracket 0 are these 3 entries, okay, for the 3 columns. So here when you write table0.size, you're saying give me the number of entries in that 0th row, and there are 3 of them because there are 3 columns. Okay, so you've gotten the number of rows, gotten the number of columns, now off you go and you can print. And let me just make sure things are matched here. Okay. Yeah, sorry. I want this in line in here. There we go. Okay. So back up in main, I can now just tell it like, hey man, print 2D vector. Which one? How about the table one? That's the only one I have. let me not print this one now. Let's just see what it does. 1, 2, 3, 2, 3, 4. Okay, the table that I created is now printed. Okay, so one of the nice things about void functions is that they make main read more like English. Okay, print two-dimensional vector. Which one? This table one, right? That's what you feed in. This is now easier to read than, say, if like all of this were back in main, right? This nested for loop structure is kind of hard to read. Maybe not for us because we've been dealing with it, okay? But this line of code in main is much easier to read. So this is part of the power of functions, making the main part of the program easier to read. You can make it more English-like. Okay. So that's the idea of a void function. For those print functions, I didn't need to return anything. You don't have to create something new to print a vector, right? You just take the vector in and then print it as you normally would, and then the function is done. Okay. Now, on to passing by reference. So this is a concept that takes getting used to, which is why we're going to talk about it in the subsequent video also. But first, let me just mention that there are two ways that you can hand a parameter to a function. You can hand it by value or by reference. To explain the difference, let me come back up here. Let me clear all of this out. I'm going to write a really simple function called func. I'm going to give it a single integer. It's going to give me an integer back. The way it will work is like this. It's going to be nice and simple. I'm going to increase the value of x by 2 and then return that value. Okay, so if back in main I say, hey, print to the screen to me, what is func of 5? You know, well, if you feed 5 in there, right, x becomes 5, and then x becomes itself plus 2, so 7, and you return 7. Okay, there you go. In main, let me actually do it like this. Int a is 5. Give it f of a, right? Function of a. It should, of course, still print 7. Okay. Now, suppose that when this is done, I want to ask the computer, what do you think a is? Well, a is 5, isn't it? Because you haven't changed the value of a, have you? So what happens here is a takes on value 5. When you feed a into this function, it's actually kind of a misnomer to say that you feed a into it. What you're actually doing is feeding the value of a into this function. Okay? The function sees that a has value 5. It then takes that value of 5 and hands it to this new variable x. Okay, so x and a are distinct in memory. The computer sees them as separate things. Okay? What is the same is simply the value of each of them. But in memory, right now you have a box with a 5 in it, right? When you feed that box into the function, it sort of like opens the box, sees there's a 5 in there, and then copies and pastes that 5 into a new box, okay? Now, I'm going to make a slight change here, and I'll explain it in a second. I'm going to put an ampersand right there, an ampersand right there. Okay. Now I'm going to hit run again. Remember this, there's a 7 here and a 5. Why is there a 7? Well, because you fed 5 into this function, didn't you? And then, 5 plus 2 is 7, return 7, right? Okay, notice what the program did. When I asked it, hey bro, what do you think A is? Or sorry, what is the value of A, right? It thinks the value of A is 7. Why is that? Okay, I didn't change the value of A. A is 5. I fed 5 into the function. The function does its thing, gives me a 7 back, right? And then I ask it, what is A? It thinks A is 7 now. Okay, now let me explain this symbol here. Ampersand, ampersand. What you are now doing is what is called passing a variable by reference. The difference is now, okay, A is a box. A has value 5, right? Now when you feed A into this function, not only are you feeding 5 into the function, You are now in memory handing the function the box a so that down here, not only does the value of a get put in box x, in memory, x and a become the same thing. They become fused. Okay, so before, without that there, x and a were separate things. A sort of tipped its value into x. Okay, now what you are doing with an ampersand, you are identifying those two boxes in memory. So a and x become the same thing. That is what it means to pass by reference. And that is why, sorry, let me go back here. That is why back in main, the value of a was changed, okay? Because a and x become fused. So x takes on value 5 right here. And then what happens to x? X takes on value 7. Okay, but you fused a and x so that in memory, a and x are the same. So whatever happens to x happens to a also. Okay? So this line of code here not only changed x, it also changed a. And that change was remembered up here in main, right? Okay, so again, when a and x are fused, whatever changes about x down here changes a up top in main, because a and x become glued together and they are the same thing now in memory. They don't just have the same value. Okay, so to pass a variable by value means what we've been doing. Only the value of the variable gets passed. The variable itself in memory is not passed, only its value. So the box itself remains untouched. The function creates a new variable to store the value that has been passed. To pass by reference, on the other hand, means to pass the variable itself in memory to the function, not just the value of the variable. In this case, the function doesn't need to create a new variable because you've given it a variable already that it fuses. Okay, so if you pass a variable x by value, the value of the variable is not changed in main because you haven't handed the function the variable x itself, only its value. If you pass a variable x by reference, the value of the variable can be different in main after the function is done running. Okay, because you've passed the variable itself. So let me show you one more example here. I can do this as much as I want. I can pass as many things by reference as I want, or not by reference. Okay, so now let me come down here. Y, %z. Okay. So what I'm going to do is I'm just going to increase x by 2. I'm going to increase y by 3. I'm going to increase z by 7. Okay, whatever. Now back up in main, I'm going to let a be 5, b be 6, c be 13. Okay, whatever. Now, when I run this function, I'm going to hand it a, b, and c. Okay. Now when I run this function, what happens? A is 5, b is 6, c is 13. I jump down here. X is 5, x is 6, z is 13. X gets increased by 2. And I'm still returning x, aren't I? So since a is still 5, when I print to the screen here, I'm still going to print a 7. Okay. After that, I'm going to print what the computer thinks the values of a, b, and c are. Okay. So remember, a is 5. A is 5 value, b has value 6, c has value 13. Okay. So when you ask the computer, hey, what's the value of a, b, c, you might think it's going to print 5, 6, and 13. Let's see what it prints. No. Prints nothing. Why is that? Well, let's see. Oh, okay. Stop. Well, take me back to the code, yo. Okay, right here. Okay, so int z. Yeah, so you have to have things match, right? Okay, let me run it. So first it prints 7, as we said, right? Then what does it print? 7, 16, 13. The value of A has changed. The value of B has also changed. The value of C has not changed. Okay, so let's talk through that real quickly, why that happened. You pass A, B, and C into this function. You pass A by reference, because there's an ampersand there. Therefore, A and X become fused. So when X changes down here, A also changes. So the value of A has increased by 2. Okay, B is also passed by reference. So B and Y get fused. So when you increase Y, well, why does it say Z there? Sorry, I meant to just write Y. Okay, so when you increase Y by 3, you are also increasing B by 3. Okay, so in the function itself, that X is the same thing as A. Y is the same thing as B. Z, though, here, when C gets passed to it, C is only passed by value because there's no ampersand there. So C and Z are not the same thing in memory. They do not get fused. Okay, so here the value of Z changes. Z has value 13 because that's what it's passed from C. So Z takes on value 20. Okay, but that doesn't matter for C because C was not passed by reference. Okay, so again, the difference is A and B have been fused in memory with X and Y. They are now the same. Any changes that happen to X also happen to A and B. The same is not true of C. C and Z have not been fused in memory. In memory, they are still separate. So changes that happen to Z don't affect C at all. It's separate. Okay, so that is how passing by reference works. So I want to conclude the video because I'm out of time. In the next video, we'll talk about applications of this. Okay, in the interest of time, I didn't show you a ton of examples. But if you combine void functions with passing by reference, you can do a lot of powerful things. Not only for us, but also if you are interested in things like memory efficiency, code runtime, etc. These things are useful. So that's all for this video.